In this video, we are going to discuss how to do survey data reduction, also known as field note reduction. We are going to talk about two methods. First method, the rise and fall method, which is probably the easiest one. Second method is the height of collimation method. With the second method, we are also going to factor in the misclosure, and we are going to do reduced level adjustment for each misclosure. Okay, so the first example is the rise and fall method. In the orange, we have all data that was calculated or it was collected in the field. How they collect this data is using a automatic level. So we have first benchmarks 10 and benchmarks 11 reduced level given. So we can go ahead and write down for the reduced level because we already know two of the benchmarks, also known as the reduced level. So that's 73.105. We can write down 72.328. Okay, the first step now, or the second step, is to find the rise and fall. How we do this is we take the backside minus the intermediate side, and if the result is negative, we are going to put it in the fall section. But if the result is positive, we are going to put it on the rise section. Now we can calculate this. 2.027 minus 2.109 is equal to negative 0.082. So we don't want to put the negative sign because we know it's a fall, so there's no need to put the negative sign. 2.109 minus 2.543 is equal to minus 0.434. 2.543 minus 4.681 is equal to negative 2.138. 4.681 minus 4.427 is equal to 0.254. 2.133 minus 3.246 is going to equal negative 1.113. 3.246 minus 1.957 is going to equal 1.289. 1.957 minus 0.681 is going to equal 1.276. 3.159 minus 2.988 is going to equal 0.171. Okay, so now we have calculated all the rise and all the fall. So now the next step is to do a sum check. Now a sum check is very important as it checks that your data or your calculations that you have done so far is correct. Now this is a very important rule I'm going to write, which is this is the sum check. So the sum check is equal to the backside minus foresight. Now that has to equal, this is the sum of backside minus the sum of foresight must equal to the sum of rise values minus the sum of fall values. Now this must equal to then the last reduced level minus the first reduced level. Okay, we need to now calculate the sum values for backside. 2.027 plus 2.133 plus 3.159, that the sum of that is equal to 7.319. Now we need to calculate the sum of foresight. 4.427 plus 0.681 plus 2.988 is equal to 8.096. Now we calculate the sum of rise. This one is equal to 2.990. Now we calculate the sum of fall. This one is equal to 3.767. Now let's calculate if we have got the sum check right. So 7.319 minus 8.096. This one is equal to negative 0.777. So this must equal to the sum of rise minus sum of fall. Now we can take these values, sum of rise, sum of fall. Let's do the calculation. 2.990 minus 3.767. Okay, that is equal to negative 0.777. Now this must then equal to the last reduced level. So this one, this is the last reduced level minus the first reduced level, 72.328 minus 73.105. That is also equal to 0.777. Okay, so now we can say this thing checks out. So we can give it a little tick. Now we can move on to the next procedure, which is calculating the reduced level. So this is actually very easy, this step, because all you need to do is add this to this. Well, if it's a fall, you actually have to minus it. But if it's a rise, you need to add it. Now, we are going to do 73.105 minus 0.082. And we minus this because it's a fall value. So that is equal to 73.023. Now we take this value here and we're going to minus it from this one, 0.434. Okay, we get 72.589. Okay, once again we do this minus this because it's a fall. That's equal to 70.451. Again, now we encounter a rise value, so this one plus the rise value, 0.254, and we're going to add it. So that will give us 70.705. Okay, 1.113. So then we get 69.592 plus 1.113. 2.289. I'm going to get 70.881. This one plus 1.276. Going to get 72.157. Okay, now to finally check it, to seal the deal, this value here plus this rise value here must equal to 72.328. So we shall do that. 72.157 plus 0.171. This is equal to 72.328. Now we can give it a little check to indicate that it checks out. Okay, so that is done. We have calculated all the reduced levels for all the points. So in this case here, because this data is made for exercise purpose, it is made to perfectly fit the last reduced level. It may not always fit this one, and you can't check this one out. This, for imagine the rise you calculated may be 0.170. That is going to be off by 0.001. So in that case, you need to do what is called a misclose, and then you need to adjust every reduced level. So we are going to look at that procedure in the next exercise. Okay, so the second method we have is the height of collimation method. Okay, in the orange, we are given the survey data along with a few benchmarks, benchmarks 10 and benchmarks 11. I have gone and copied these to the RL table. The next step is to work out heights of instrument and fill this whole column. And we need to do that before we worry about the reduced levels. An important rule is height of instrument equals backside plus reduced level. Another important rule that we may need in a while is reduced level equals height of instrument minus foreside slash backside slash intermediate side. Okay, now we can have a look at our table. So height of instrument equals backside plus reduced level. We already have a backside here and we have a reduced level here. So we have all the components needed to calculate height of instrument. Let's do that. 73.105 plus 2.027 equals 75.132. Now, there's only one height of instrument per setup, and there's 3 setups. 1, 2, and the last one, 3. This first setup has 1, 2, 3 intermediate points. So for these 3 intermediate points, the height of instrument is going to be the same, because intermediate points do not require a different height. They are the same station. We're just going to look at this example here. So this is station 1. No matter how many points, intermediate points there is, it could be 1, 2, 3, 4, 5, 6, 7, 8. It does not matter how many intermediate points there is, the height of instrument does not change. So based on that principle, we can go ahead and copy these 75.132 for the 3 intermediate points, because once again the height of instrument does not change for intermediate points. Now we have the start of a different setup. See, we have a different backside. That means we need a different height of instrument. We'll just refer to the drawing here. This is the new backside, like here, 2.133. This is the new backside. And for this backside, we are using a different station. So we need to work out the height of instrument. Now the height of instrument is equal to backside minus reduced level. But once again, you can see here, we do not know the reduced level for this. Therefore, we need to refer to this equation. Reduced level equals height of instrument minus foreside or backside or intermediate side. So we can just take the height of instrument here and we minus the foreside here, and we get the reduced level here. So 75.132 minus 4.427. So now we get the reduced level, which is 70.705. So now we're going to calculate the height of instrument. Because we got the reduced level, we can go ahead and add the backside to the reduced level to get the height of instrument here. So 2.133 plus 70.705 is going to equal 72.838. And once again, we have 2 intermediary points. And like I said before, for intermediate points, the height of instrument does not change. So we can just copy these ones for these 2 stations here. Now we have a start of a new setup. We have a new backside. That means we need to calculate the reduced level here, just like we did with this one. So we will once again refer to this rule. Reduced level equals height of instrument minus the foreside, backside, or intermediate side. So we are going to get this one minus this one, and we are going to get this reduced level. So 72.838 minus 0.681. So we got 72.157. 72.157. Okay, perfect. Now we have the reduced level. Now we need to add the backside to get the instrument height. So reduced level here plus backside here will equal the height of instrument. So we can just do that. 72.157 plus 3.159 equals 75.316. Okay. Now we have once again, this is the same setup, backside, foresight. So we can once again assume this one remains the same. Okay, now we have the height of instruments. Now we are able to calculate all the values for the reduced level table. Once again, we can refer back to this important rule. Reduced level equals height of instrument minus foresight slash backside minus intermediate side. So we already have the reduced level here, so we can start with this. We need to go ahead and minus 2.109 from 75.132. We'll do that. 75.132 take away 2.109. So now we have the value here, 73.023. Okay, next one, we are going to go ahead and minus height of instrument from the next intermediate side. We get 72.589. Okay, next one, height of instrument minus intermediate side, we get 70.451. Okay, next one we already had, we calculated it previously, so we can skip that one. So next one, we're going to get 69.592. Next one, we're going to get 70.881. Okay, next two are already calculated for us. So we are actually going to do a double check on this, because this is the data from benchmark 11, but we did not calculate this. So we're just going to calculate that again, see if it equals to 72.333. So we have the reduced level here. We're just going to minus the foresight, see if we get 72.333. So 75.316 minus 2.988. Okay, so there is a slight problem. We got the result of 72.328. Okay, so we have essentially got less than what we would have liked to. So this is supposed to be the real benchmark, but instead via our calculations, we have got a value that is less than the benchmark 11. So we got a value less than what we would have liked. So we're just going to, so the next step is to go ahead and go ahead and calculate our misclose. Now our misclose is equal to the calculated RL minus the known RL. Now this is equal to, so the calculated RL, we got 72.328. The known RL is 72.333. We need to minus these values together to get our misclose. So this is, I should say, misclose equals calculated RL minus known RL. So we're going to put 72.328, 72.333 minus these three values, and we get a misclose of negative 0.005. Okay, now that we have calculated our misclose, we are going to go ahead and calculate our adjustment values. Now adjustment values are here. So we need to go ahead and calculate the values that are going to populate this table. So I have written down an important rule once again. The adjustment values are equal to the misclose divided by the number of setups. Now let's count how many setups we have. We have one setup here, we got two setup here, we got three setup here. So 1, 2, 3. This will be equal to minus 0.005 divided by 3. And this is going to equal 0.0017. Okay, that's negative. Another thing with the adjustment values is that if your value is negative, then you are actually going to add it to the adjustment, to the reduced levels. So we are not going to put the negative sign here. We are just going to put 0.0017. Now the first value here does not need to be adjusted because it's a benchmark. And benchmarks we can assume they're correct because they are not measured by us. They are already given to us, so we can just assume that's correct. And the adjustment for the first one is going to be 0. For the second one we calculated is going to be 0.0017. Now it is it's an adjustment per setup, so you don't need to add adjustment to every single value. It's per setup. So we can just say here the adjustment values for these three are going to be the exact same. So we'll just write 0.0017, 0.0017. Okay, now we have approached the next setup. So the trick with this one is, this is also very important. Adjustments are accumulative. So for this adjustment, you are going to add another set of another 0.0017 to the 0.0017. So we can just write here adjustment for first setup equals 0.0017. Adjustment for second setup equals 0.0017 times 2. Adjustment for third setup is going to equal 0.0017 times 3. So let's go ahead and add 0.0017 to the 0.0017, and we get 0.0034. And once again, this is the same setup, so we can just copy this one down until we reach our final setup. Now we're going to times here. And once again, remember that adjustments are accumulative. 3 times 0.0017, that's 0.0051. Okay, 0.0051, 0.0051. Okay, now that our adjustments have been made, we can go ahead and add the adjustment to our reduced level. So this is the easiest part. We're just going to add the reduced level plus the adjustment, and this is going to go here. 72. And with the final one, we have to make sure that 72.328 plus 0.0051, it equals 72.333. So these two add together has to equal this one, and it checks out 72.3331. So we can just give a tick to this to confirm that it's correct. And then, well, that is our adjustment values complete. Thank you for watching, and good luck with your studies.